Okay, so now let's talk about galactose and fructose, all right? Uh, okay, so let's start out with fructose, okay? So fructose, the female gypsy, free spirit, she's in the blood, she can enter cells, leave cells, but if she gets into a cell and interacts with fructokinase, that's going to add a phosphate and arrest her because she's a okay, so yeah, first thing that happens with all of them, remember, is the phosphate gets added. So there's fructokinase, glucokinase, and galactokinase. Glucokinase, depending on which tissue, can also be hexokinase. But the point is, you take the name of the thing and kinase, that means that, say with fructokinase, a phosphate is going to be added onto the fructose, so you just get fructose with a phosphate on it, okay?
What is the difference between a kinase and just an ACE? ASE, as in catalase.
I don't know, does anybody?
So phosphorylate stuff, right?
Yeah, a kinase will transfer a high energy phosphate.
Okay.
I don't know, catalase, I don't know.
I mean, every enzyme ends in ACE.
Yeah.
So ACE is just like the ending
Generic.
of an enzyme.
Yeah.
So like
Kinase is a subset of ACEs.
Yeah.
Mhm.
So kinase phosphorylates things, then you have like
Phosphatase is what they
phosphatase will
Yeah.
take away.
Cool.
phosphate.
Thank you.
Okay, so first step, as with all three of the sugars, the fructose gets arrested. Now, now this time, there's no beard, right? There's no beard, so they automatically go to the chop in half step, right? So remember how with glucose, first they had to tug on the beard, find out that the glucose was actually a female, and then they chopped her in half. With fructose, she gets arrested and she's female, so they just chop her in half right away. Okay? So that's aldolase. And then she'll either go to dihydroxyacetone phosphate for dihydroxyacetone atone with a guard, or glyceraldehyde. So see how this is different? There's glyceraldehyde 3-phosphate over here, which has a guard. But glyceraldehyde over here doesn't have a guard, right? So with fructose, they jumped the gun, chopped her in half before there were 2 guards. So remember how I said you always have to have 2 guards for every suspected witch? Well, this is why. Because if you chop her in half before there are 2 guards, there's only going to be 1 phosphate to guard one of them, and the other one is possibly going to go rampage and cast spells and stuff, right? So the good half, the one that's going to atone, has the guard, and then the glyceraldehyde, lion hide one, or you could think about it as Jekyll and Hyde, Mr. Hyde, the evil one, doesn't have a phosphate over here, so it's just going to run wild. And then 1 of 2 things can happen. A guard can successfully arrest that glyceraldehyde, in which case we're at glyceraldehyde 3-phosphate, right? Just like over here, right? And then this would follow the same path to the pyre to get burned, right? Or it cannot get arrested and be converted into glycerol. But in the end, let's see. There's some more detail there, but I'm going to skip that for now and just say, in the end, it gets arrested, becomes glycerol 3-phosphate, which is used in fatty acid synthesis. And I'll go into that detail more when we talk about fatty acids. So for now, does that make sense? The female gypsy gets into the cell, she gets arrested, right? First step for all of them. So we're at fructose 1-phosphate. They jump the gun and she gets chopped in half right away. Goes from 1 6-carbon molecule to 2 3-carbon molecules. And because they didn't have two guards there, one of them has a phosphate and one of them doesn't. The one of them that has the phosphate is the same thing as glucose. You get to dihydroxyacetone with a phosphate. The other one is glyceraldehyde, which would be just like with glucose. See how that's the same? It just doesn't have that second phosphate, okay? See how that's the same? And this enzyme and this enzyme are both aldolase, okay? Anyway, that glyceraldehyde can get arrested, in which case we're right back at the same place, okay? So you can think about glucose and fructose as being very similar, all right? So now, galactose, okay? Galactose is just like glucose, just a couple of tiny differences. So anyway, the galactic gypsy guy gets into the cell, he gets arrested. Then there's an enzyme, UDP, let's see, galactose 1 uridyl transferase, okay? So if a gypsy guy got into the cell and he had a space helmet on, what's the first thing you think that the witch hunters would do?
Take the helmet off.
Yes, exactly. They take the helmet off. So yeah, uridyl transferase, you get rid of that. The galactose 1-phosphate is converted into glucose 1-phosphate. All right, so that's an irreversible step. They actually break his hat. They take it off and smash it, okay? So the galactose 1-phosphate is converted into glucose 1-phosphate. And then that's converted into glucose 6-phosphate, and then it's the same thing, okay? So when you think about these sugars and you think about glycolysis, remember that glucose, fructose, and galactose are all very similar, and the steps that, see, they all have the same first step with a phosphate, and they are all going to end up either at G6P, dihydroxyacetone phosphate, or glyceraldehyde 3-phosphate, okay? And then those are going to end up at pyruvate. At which point, the witch is about to be burned. She can escape death temporarily by saying that she's pregnant, in which case she goes to the liver until she has the baby. Or she can deny Allah, in which case she's taken to the liver until the witch hunters figure out that they're going to burn her anyway. So they convert her back into pyruvate, okay? And if she's actually going to get burned, there's the enzyme there, pyruvate dehydrogenase. Tinder lighting causing fire now. CO2 is given off. 3-carbon molecule goes to the 2-carbon molecule. Okay? Okay, so that was glucose, galactose, and fructose. Okay, so let's talk about okay, do you all need to know essential fructosuria?
Yes.
Okay. Do you need to know fructose intolerance?
Yes.
Do you need to know galactokinase deficiency?
Mm-hmm.
Classic galactosemia.
Yep.